Included this table here to recap some of the information. There's a ton of information on hypersensitivities, but again, we'll just go through the big stuff here. Remember, type 1 hypersensitivity, the classic term we use to describe this is immediate because we have the preformed IgE antibodies on the mast cells and on the basophils. Remember, you have to have a second exposure though to get to that point because we had to class switch to get those antibodies onto the mast cells and the basophils. The early phase is the phase that's classically asked about. Probably the most important thing to remember here is that we have mast cells and basophils along with preformed IgE that will cross-link when antigens bind, degranulation, histamine release. Remember, tryptase also, you can measure the serum for that. And then the late phase, remember eosinophils, but not quite as high yield. Urticaria, very classic initial symptom. What are we worried about? Anaphylaxis. If we're testing for it, we can test tryptase, which also gets released in the granules. We talked about that. You can do skin testing to look to see what exposure potentially this patient has had before. We talked about the key components here, and then some of the key examples, food allergies, insect stings, even certain medications being very classic for that. Remember that type 2 hypersensitivity, we kind of broke it down in a few different categories. Really cytotoxic and inflammatory are similar. Inflammatory I just put on here because you have certain tissues that will have effects as opposed to just like one cell. The key between type 2 inflammatory and type 3 hypersensitivities is that type 3 involves immune complex formation, whereas type 2 does not. Okay, so that's particularly high yield. Type 2 cytotoxic, we're talking about cell destruction, tissue destruction, and then we can bind to receptors, essentially block receptors or stimulate receptors. Okay, and so we kind of talked about all that here. The complement cascade intricately involved with the effects that we're going to see when antibodies bind to host surface cells via some antigen. And remember also, you have natural killer cells involved with antibody-dependent cell cytotoxicity. Autoimmune hemolytic anemia was very classic. We talked about the direct Coombs test to look for antibodies actually on the cell, and then the indirect Coombs test to look for antibodies in the serum. Okay, and you can also just simply measure a serum antibody. And then here's your classic examples. Talked about all of this in pretty great detail in the video already, so I won't go into too much detail here. Type 3, again, remember the key thing here, immune complex formation. Okay, immune complexes that are getting deposited kind of systemically. And the big thing is you're going to have much more significant amount of complement released on average here when you're talking about type 3 hypersensitivities. Vasculitis, arthritis, glomerulonephritis are very classic. You can measure the complement levels because of that extreme amount of complement activation. Finally, we talked about the type 4, very classically called the delayed or cell-mediated. Remember, these are all humoral. Type 4 are primarily going to be talking about T cells that are causing most of the havoc here. And the big one is the CD8 positive T cells activated via MHC1, but we can also see a T helper 1 response, largely driven by interleukin 12, interferon gamma. Okay, we talked about the tuberculin skin test, Candida skin test being more so used as a control to see if there's actual T cell function, as most people are exposed to Candida, tuberculin, then testing for tuberculosis, right? And then we talked about some of these different cell lines involved and some classic examples here. So a lot of information in this video. Hopefully you found some of this helpful, and I think the table does a pretty good job of just summing up the big key points.